He's about it. And he was religious. He's like, I live so far away from the blah, 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 like there's traffic. I was like, look, like, you know, my commute's over an hour. If somebody's consistently coming up, you need to make adjustments to your schedule here. All right, 38. Read out the answers. Good morning. Have a seat. Get out the homework so I can check it. Give me 10 push-ups and get dress code. Number 1, 1,560.
I got that one.
2 is negative 10. 3 is 5. 4 is negative number. 5 is 49 times 100 over 2.54 times 12 feet.
5, we didn't do 5.
Well, oh yeah, they are cool 5. 6a is 6 centimeters. 6b is 12 pi centimeters. 7, on your number line, you should have an open dot on the 2 with the arrow pointing to the left. 8, x is less than or equal to negative 2. 9, 1 over 36. 10, negative 1 over 25. 11 is 6. 12 is 2. 13 is negative 13 over 28. 14 is 4. 15 is 4. 16 is 7. 17 is 4a squared x squared y to the 4th, open parentheses, xy minus 2a squared. 18 is 6a squared x m to the 5th, open parentheses, m minus 3a cubed x squared, close parentheses. 19 is x minus 3. 20 is x minus 5. 21 is 3xy. 22 is 12z minus 21x squared y to the negative 3. 23 is a squared x cubed over c cubed minus 3a squared over x squared. 24 is negative 72. 25 is 10. 26 is negative 49. 27 is 8/3. 28 is 96 plus 50 pi square meters. And 30 is 912 square feet. Any answers anybody wants repeated?
So, I just realized that Mr. Brown's name in Spanish would be Senor Marron.
Which one?
Number 24.
24? 24 is negative 72.
Wait, for 23, you could cancel them out.
Cancel what? Yeah, so in that second fraction, the c squared on top and the c squared on bottom will cancel out. And the x on top and the x cubed on bottom, the x on top will get canceled out. You'll be left with x squared on the bottom. All right, problems you want to go over?
Number 24.
Number 24, all right. So we're on page 155 here
Wait, what the answer is that?
to 24, negative 72. Page 155, number 24, k squared minus k cubed. K squared minus k cubed times k m to the 0. If k equals what?
Negative 3.
Negative 3, and m equals
2.
2. Okay. Before we do anything else, why don't we simplify this a bit?
K 0. Well, K 1. I don't know. K times 1.
Yeah, right. K times m to the 0 is just k. Can we simplify this any further?
No.
Yes.
Yes.
How can we simplify this further? Dress code, please. How do we simplify this further? What's k cubed times k?
Well, K to the 4.
Yeah.
So,
And this simplifies to k squared minus k to the 4th.
how is that?
Now, we can just forget about m equals 2. Doesn't matter what m is. K is negative 3. So we've got negative 3 squared minus negative 3 to the 4th. Yes?
Yeah.
Yes, you see how I put the parentheses in there? Always important, especially when the value is negative. What do I do first?
Yeah.
Yeah, so what operation am I going to do first? Not multiplication. Exponent, right. So what am I going to get? 9. Negative 3 squared. When I'm squaring, notice it's negative 3. So it's negative 3 times negative 3. Two of those multiply together, I get positive 9. And what's negative 3 raised to the 4th power?
A positive 81.
81, right, positive 81. Notice there's still this minus sign in there that got carried over from here.
But it turned it into
No.
Yeah, that's what I did. I thought it was.
Yeah, so notice, negative 3 to the 4th is what?
That's 81.
Is positive 81. But notice it's minus negative 3 to the 4th. So we're subtracting that positive 81.
No.
Yes, that's how we got our negative 72 here. Be careful with those negative signs when we've got exponents involved.
I'm not surprised.
We're just changing this part here, negative 3 raised to the 4th. That becomes 81. There's nothing that we've done at that point which should affect that subtraction. The only thing that might affect that subtraction is some multiplication. But there is no multiplication in this one. There's just exponents and then subtraction. Yes?
Are you giving us homework?
No.
Yes.
No.
Thank you.
Go enjoy Thanksgiving with your
Mr.
family.
Rose. Insane.
Ashton said that he ain't coming.
I felt like every other
He had a
day.
headache.
Mr.
Okay. Thank you for letting me know. All right. You don't need to complain about things.
He got a Spanish.
Okay, other questions about this lesson set? How did you guys do with number 1? In numbers 1 through 4, I should say.
I did.
I got 1,560.
Yes, that's correct.
Wait, and I got 7 1/5.
I did not get number 3 right.
3. I don't think I got it right either. I got 281.
No.
I got 1, 24.
Okay, so the answers for the first 4, now you can check them out. 1 is 1,560. 2 is negative 10.
Whoa.
3 is 5. And 4 is a negative number.
I got 1 and 4 right. I did not do 10. I did not do 2. And I got 3 wrong.
Okay, so
2 out of like 20.
What number? 1 went okay? Yes? General, 4 went okay?
Yes.
Okay, so it's just 2 and 3. So 2 and 3 are the same type of problem. Let's do these both, because these just take practice. The issue with these is setting up your algebraic equations. So that was 24, right? So let's do 2. If the product of 5 and a number is increased by 8, the result is negative 42. What is the number? First thing we got to set it up. The product of 5 and a number is increased by 8, and the result is negative 42.
The product of 5 and a number.
What is the product of 5 and a number? Right, 5 and what operation is connecting them? Multiplication. Product means the result of multiplication. The product of 5 and a number. Then what happens to the product of 5 and a number? It's increased by 8. What does that mean? How do I write that?
Plus 8.
The result is negative 42. Yeah, just equals negative 42. Right, the product of 5 and a number is increased by 8, and the result is negative 42. If we do that, then what's the number? If that's the case, then what's the number? Yes?
Yeah.
Everybody's...
I am retarded.
Negative 50.
So, right, so we subtract 8 from each side, we get negative 50, 5n is negative 50, and then n is equal to negative 10. It's just a matter of setting that up. The product of 5 and a number is increased by 8, so the product of 5 and a number, 5n, increased by 8 plus 8, the result is equals negative 42.
Oh, because I think I just read the problem wrong. I put minus 8.
Ah, yes, it's increased by 8, not decreased by 8. Yeah, that would definitely throw you off. All right, what about 3?
Yes.
3 is definitely more difficult.
Anyone got Hanson inside of there?
There's...
It used to be over there. There hasn't been any in this classroom for like a solid.
Wait, actually, I
like,
got one in my bag. But I think
Okay, so how do we set up number 3? Twice the sum of 3 times the number and 60 is 155 greater than the opposite of the number. Find the number.
Alright, so 3 times n, 3n plus 2.
What?
Never mind.
That's like
Yeah, I'm not.
2, put in like parentheses.
Oh.
And
Yeah.
6, right? Then it equals 155 minus 9.
Yeah. Okay, this is correct. Now, why? We have to take this one step at a time. Read from the beginning. Twice the sum. Twice the sum. Twice means what?
2
2
times.
2 times, right. 2 times what? I think I follow along. 2 times what? Twice what?
The sum.
The sum. Okay, that means that we're taking some sum. The sum is the result of what operation? Addition, right? So we're doing some addition, and the result of that is what gets increased by 2. When you see something like twice the sum, a good way to write that is 2 outside the parentheses, and then there's addition inside the parentheses, right? There's some sum that we're doing, and we need twice that, yes?
yes.
Okay, now the sum of what? Twice the sum of what? The sum of?
3 times the number.
Okay, 3 times the number is the first thing that we're summing. It's 3n, and what else?
60.
And 60. This is twice the sum of 3n and 60. Right, the sum of 3n and 60 is here, twice that. We put the 2 there. It's 155 greater than the opposite of the number. Okay, now, if we say 155 greater than the, what do we say for opposite of a number?
Negative.
Negative,
N.
yeah, negative n, okay. Negative n. If this is 155 greater than this one, how are we going to make them balanced?
Equals.
If this is 155 greater than this, how can I set it up with that 155 there?
Or equals plus 100.
Equals, right. Negative n plus 155. Why? Because if this is 155 greater than the opposite of the number, in order to make them equal, I have to add 155 to this side. That, I think, is the hardest part of this one, is doing that correctly. You have to either add 155 to this side or subtract it from that side. Because they give you 2 things. They say twice the sum of 3 times the number is 60, and negative and the opposite of the number. This one's 155 greater. But we're not going to be able to solve this equation unless it's an equation, unless it's balanced, unless there's an equal sign between them. So how do we make these 2 things equal to each other if this one's 155 greater than it? If this one's 155 greater than this one, we're going to have to do what?
Subtract.
Subtract where?
155.
From where?
From
Yeah, we could either subtract 155 from the left to make them equal, or we could add 155 to the right. Yes?
Yes.
Either one of those is fine. Okay, here we're adding 155. You could also write this 155 minus n.
Yes.
Do you understand how we set this up? Okay, so a couple things going in here. First off, 2 times the sum of 3 times the number, or twice the sum of 3 times the number and 60
6
is 155 greater than the opposite of the number. Okay, now in order to solve it, what do we have to do?
distributed property.
Distribute out the 2 to get rid of the parentheses. So what are we going to end up with on the left?
6n plus 120
6n plus 120.
equals negative n plus 155.
Yep. Now what do we do?
Subtract 155.
Combine. Move like the n on the left and then subtract 120.
Right. So we combine any like terms, which we can't do. We'll move the variables to one side, the constants to the other side. It's easier, I think, to move the variables to the left. Add n. Move the constants to the right. So subtract 120. And what do we get? We get 7n equals.
7n. Wait, isn't that n right there negative? And the 6n is positive. So when you 5n,
This was negative n. So how do we get rid of negative n?
when you add it.
We add n. Right.
7n equals 35. 5.
7n equals 35,
N
so
equals 5.
n is 5, yes. That's how we got there.
Oh, I got. Oh, I. Okay. So like for the parentheses,
Mm-hmm.
I forgot to put the n, so I combined the term
Ah,
and yeah.
yeah, you gotta remember when it says something like 3 times the number, we always gotta write that variable there. That'll throw you off, yes. Questions about either of these? Or any other problems from the homework?
Number 28.
28. Okay, we're finding the area. What kind of shapes do we have there?
I have no idea. A triangle, circle,
The triangle and
circle,
nope.
half of a circle.
Yeah, and a semicircle and half of a circle. So the triangle, how do we find the area of the triangle here, 28? Right, it's base times height divided by 2. What's the base and what's the height of this triangle?
12 and 16.
Yes, the base and the height of a triangle have to be at right angles to each other.
Yeah.
So 12 and 16 will work, so we do 12 times 16 over 2, what do we get?
Wait, 96.
96, yes. The easier way to do that, I think, is to divide the 16 by 2, so we get 12 times 8, which is 96. Okay, 96, what's our unit? Meters. So 96 what?
Meter.
Not meters,
Square.
square meters, right. Okay, what's the area of the semicircle? How do we find the area of half the circle?
Pi r squared.
Well, that's the area of a circle, so how do we find the area of half a circle? Yeah, pi r squared divided by 2.
Yeah.
What's the radius of the circle?
50. Oh, 10.
10, so it's pi times 10 squared divided by 2. What's 10 squared?
100.
So 100 pi divided by 2 is what? 50 what? 50 pi
Squared.
square meters. Yep. So what's the area of the whole thing?
Let's see. 50 pi square meters plus 96 meters.
Yeah, 96 plus 50 pi square meters. You don't have to multiply out the pi. You can just leave it in there. 96 plus 50 pi square meters.
Okay.
That's all. Okay, just a semicircle, it's just a circle and then divided by 2. All right,
Wait, what was the answer for 8?
8. Number 8 was
Something.
x is less than or equal to negative 2.
Oh, I put -1.
Less than or equal to negative 2. So notice where the dot is on the negative 2. So x is equal to negative 2 is a solution because it's a filled-in dot, and x is less than negative 2 is also a solution. So we can write less than or equal to. Okay, let's move on to page 156, lesson 39. 3 things to talk about here.
After everything clear, everything.
I mean, there will be time left over that you could either start on the homework, which I'll make due on,
Homework.
You said there would
which I'll make due, I mean, I'll tell you what it is today, but it's not going to be due until our second day back from break, which might be Tuesday, but it might in fact be Wednesday,
Well, how did that work?
because we may or may not have classes on Monday. We have to make some adjustments to the building.
Oh.
Uh,
Kind of adjustment.
We're going to be splitting up the building into smaller sections to decrease the amount of contact between different groups of students.
So we're gonna like make the classes like
What are
smaller?
they?
No, it's just that the building is going to be split up into 3 sections, and so you'll just stay in one section of the building, and
The
there'll be
whole
some
time?
designated outside areas. Yeah, so you won't be like having class in all different portions of the building. So like you guys won't have any classes in that wing of the building, for example.
Oh.
There are some high schools who have classes off in that wing
We
of the
still
building.
have classes on that side of the building.
Yes.
Oh, so it's like one section, so like
Yeah.
2 different. Okay.
Hang on, get to see my brother-in-law.
Okay. All right. Okay. So 3 things. First off,
That's what we're gonna.
the trichotomy axiom.
Can you speak?
Do you guys know the word axiom? Axiom. No, axiom. What's an axiom?
The word I do not know.
Okay. An axiom, like many things in Greek, A-X-I-O-M, comes from Greek, like many math words. An axiom, it comes from the Greek adjective axios, which means worthy. An axiom is something that just on the face of it is worth accepting as true. It's hard to prove an axiom because they're just sort of fundamental things about the way that the universe operates. That's what an axiom is. Trichotomy is also from Greek. It's from trichos, meaning three ways, and tomos, meaning cut. Cut three ways. So trichotomy is there are only three options. What are those three options? The trichotomy axiom tells us that if we've got two numbers, two real numbers, A and B, there are only three possibilities. Either A is less than B, A is equal to B, or A is greater than B. Right? This is pretty obvious. Any two numbers, any two real numbers, either they're equal to each other or they're not. And if they're not equal to each other, one of them has to be greater than the other. There are no other options. Yes? Yes? Yes, this makes sense? Okay, you can't really prove this. It's just sort of a fact about the way that these things work. That's why it's called an axiom. Okay, now, what does that mean? Given that these are our only three possibilities, we've been talking a little bit about inequalities. We can also negate our inequalities. Yeah. What does that mean? Okay, the same way that we've got this symbol, right? What does that mean? Equals. Okay, we've also got this symbol. What does that mean? Not equals. Okay, all that this means is that of these three options, we're eliminating the middle one, right? We're either saying the first one's greater than the second one, or vice versa. Yes?
Yes.
Okay. We can negate the inequalities also. This is negating equality. We can negate the inequalities also. So we can have less than. We can also have not less than. So if we say this, what are our options? If one thing is not less than the other one, what are our options? Yes. Notice, this is the same thing as this. If we say that the first number is not less than the second number, that leaves us with two possibilities. Either the two numbers are equal, or the first one's greater than the second one. Right? Yes? So not less than is the same as greater than or equal to. What about greater than? Not greater than. What's another way to write not greater than? Less than or equal to. Right? Because if we take away greater than as an option, the two options left are less than and equal to. What if we say not less than or equal to? What's the only option left if we say not less than or equal to? Greater than is the only option left. Right? If we remove those two options, that's the only one left. What if we say not greater than or equal to? Oh, wrong way around. Not greater than or equal to. What's the only option left? Less than is the only option left. So because there are only three options, when we take an inequality or the equal sign even and negate it, it leaves us with at most two possibilities, sometimes just one possibility. Yes?
Yeah.
Yes? Okay. That makes sense?
Yeah.
So I could say, for example, x is not less than 2. What's another way of writing that? Maybe an easier way to understand, to write x is not less than negative 2. The x is not less than 2.
2, x is greater
Or
less or equal to.
right. These are the same. These are the same as each other. Yes?
Yes.
Yes? Okay. We could graph both of them the same way on the number line. They're both going to be graphed this way. Because they're equivalent. They're the same. This one, I think, is generally speaking easier for us to understand. Right? This one saying not less than, okay, but saying equals is an option, or greater than is an option. That's easier to understand and easier to graph. Questions about that? Okay, now ratio problems. Yesterday we had ratio problems, not so complicated so far. Today they're going to become a bit more annoying, shall we say, a bit more involved. Okay, so let's use the example problem here. Example 39.3 on page 157. They tell us the ratio of red marbles to blue marbles is 5 to 7. If there are 156 marbles in the bag, how many marbles are red?
At least four.
At least 4. I guess that's true. Not less than 4. Right? At least means greater than or equal to. Means not less than. How are we going to solve this? Now, normally when we see the ratio of red marbles to blue marbles is 5 to 7, what are we going to write?
2, 5, 2,
Okay, so, but what is 5 over 7? Yeah, R over B is 5 over 7. Then what do they tell us? Okay, so where do we plug in the 156?
You put X, or you put
One
RB, and then 156, 600.
156 over B equals 5 over 7.
So there's 156 red marbles?
Yeah.
No, they're asking us how many are red. What is the 156? 156 is what?
All the marbles.
Is the total number of marbles. Oh crap, I don't have a place to plug in total number of marbles here. So, what are we going to have to do? Here's what we do. Listen. We can follow the ratio and add in another aspect to it. If red to blue is 5 to 7, the problem is they give us the total. Yes?
Yes, sir.
So what we really want is we want the ratio of red to total. Because total is what they gave us and red is what we're trying to figure out. We don't actually care about the blue marbles. Yes?
Yes, sir.
Okay. Red in our ratio is what?
1. We don't know.
Red is what in the ratio?
Oh, 5.
Red is 5 in the ratio. What about total?
156.
No, total. That's the total number of real marbles.
12.
Where'd you get 12 from?
Oh. 5 plus 7.
Right. If in our ratio, the ratio of red to blue is 5 to 7,
Oh, I was right.
we could also say that the out of the total, for every 12, 5 of them are red. That means the same thing. We can add these two together and we get the ratio for the total. Right? Red still, we can keep 5, red is 5 in the ratio. Total in the ratio is the reds plus the blues, 5 plus 7. Now we can plug in our 156. Where does the 156 go?
Right over there.
Where? Right, so R over 156 equals 5 over 12. How do I solve now?
Cross multiply.
Cross multiply.
Wait a minute.
What am I going to get?
12R equals
156 times 5.
5, 3, 5, 3, is that like 800?
800.
800, 700, 600, one of those.
One of those. Come on, somebody do it. Do it by hand if you need to. Shame in doing this by hand.
Alright, so yeah, I should have brought like my baggage.
780.
Yes, 780.
780.
Yep, 5 times 6 is 30, plus 5 times 5 is 250, gives us 280, plus 5 times 100 is 500. Okay, 780, then we do what?
Divide
Divide by,
12 on both sides.
yep, what are we going to get?
You're gonna get it.
This. If you want to do it quickly, often, I don't know about you guys, I really don't like dividing by 2-digit numbers. Right?
Yes, sir.
Yeah, I don't like it. But we could simplify this first before we divide. So how can we simplify this? What can we divide out of both 780 and 12?
5.
2, or even better would be
6, -1.
Yeah, we could divide 6 out of both of them. Yep. What do we get when we divide 780 or 4? 2, 4, 6 will work. What happens if we divide 6 out of both of them?
2.
2 on the bottom and
72.
don't add 6's up. Come on, divide 780 by 6.
80.
780 divided by 6. How many times does 6 go to 7?
1.
How many left over?
1.
Okay, 6 goes into 18
3.
3 times. 6 goes into, with how many left over?
0.
Okay, 6 goes into 0 0 times.
130.
Ah, now this is much easier. What's 130 divided by 2?
Well, that's the, yeah.
75. Wait,
All right.
no.
130 divided by 2.
65.
Yeah.
That's what I said.
Okay, yeah, 65. There's our answer. If there are 156 marbles total, then 65 of them are red.
Yeah.
2 things here. One, the second thing is that we've already done is solving once we get this ratio set up. But the first thing is figuring out how total will go into the ratio. We could write R over B is 5 over 7. We could write R over T is 5 over 12. We could write B over T is 7 over 12, depending on how they want us to do it, right? If the ratio of reds to the total is 5 to 12, then the ratio of blues to the total is 7 to 12. We can do any one of these to give us. Uh-oh. Looks like my computadora froze.
Mr. Bossy doesn't let us say that. Why? He wants to say ordenador.
Yeah, because
I've never heard anyone use that word before.
because it says a bad word in it, supposedly. He doesn't like to.
Well, it's possible that he has had students in the past who have abused the fact that there's some inappropriate word in the middle of that word. That would not surprise me if some Avalon students in the past or recent past had done that, had decided to emphasize certain syllables of a word. All right, any questions?
I wonder who those students could
Okay, listen, this is going to be due either Tuesday or Wednesday, whatever is the second day of classes after the break. Is going to be, what is this, 39 now?
Yes, sir.
Yeah, all except 5 and 7. If you have test corrections, leave them on my desk. All except 5 and what did I say, 7?
You said,
He said,
5,
5,
7, and then 20 through 30.
All right, well, looks like the stream did end up working again. All right, goodbye. Homework will be due the second day of classes after we get back. So either Tuesday or Wednesday, depending on what happens with Monday. We may not have classes Monday. And it's all except for 5 and 7. Thank you very much.